Assalamu alaikum students. In today's lecture you will learn about the significance of the general gas equation, then the different values of R, that is at STP and SI units, or in ergs or different one units they will be discussed. Then there will be the factors related to that of the deviation from the ideal gas behavior, they will be explained. Okay, now come to the next one. Here we have the significance of the ideal gas equation. As we have derived it in the previous one lecture, you know very well that the equation is given as PV is equal to nRT. Now from this ideal gas equation we can calculate the molar volume, molecular mass of the substance, as well as we can calculate the density of the gas. Related to this, there are given a number of numericals in the form of examples. You have to go through these all examples very well. I'm not going to explain them all here. All they are very simple, and if you get any problem, so you can ask me on the WhatsApp, right? Self check we will do on the WhatsApp. Okay, now here we have the calculation of the molecular mass of the gas is given by means of the equation, that is PV is equal to nRT. How it is being calculated, you know very well. Here the P represents pressure, V the volume, N represents the number of moles or the number of particles, R represents the constant, that is general gas equation constant, and T is equal to the temperature. Now what is N? N gives you the mole. Moles is equal to, you know very well, it is the given mass over the molar mass. If we apply this term instead of N in this equation, so you will get that PV is equal to W upon mRT, right? Now rearrange this equation by taking the m on the other side, and it will turn like this: PVM is equal to WRT. Now we want to calculate only m from here, that is the molecular mass. So what you have to do, make this a PV to move on the other side. So you will get there m is equal to WRT upon PV. This is the equation you have to remember, which will be used to calculate the molecular mass of the gas. Similarly, to find out the density of the gas, now here we rearrange this equation once again. You know very well now that PV is equal to W by mRT from the above one statement. Here we have MP is equal to W by VRT. Here we have moved the V to the other side. This becomes MP is equal to, as you know, that W by V, mass per volume, is equal to D, that is density. So MP is equal to dRT. You want to calculate D, that is density. So it will turn like this, that D is equal to MP upon RT. I hope you understand it well. That very simple you have to do with the general gas equation. The changes, you know very well, they are very simple. You have learned them before, right? So apply them. You can find now the density as well as the molecular mass of the substance from the ideal gas. Okay, now here the numerical values of R, that is the general gas constant, has been calculated at STP and that of SI units. Then first of all, find it out in STP units. What the values which you will get, they must be used in the numericals which are related to the gases, right? Now here the two values you have to learn them well, that is the value of the R. Okay, now here in STP we consider that the equation is PV is equal to nRT. You are familiar with it. Now PV is equal to nRT, where P stands for pressure in atmosphere, V in volume for 1 mole of the substance, N is the 1 mole of the substance or the gas, R is the general gas equation, and T represents the temperature in Kelvin scale. Right, now write down all the units along with it. The unit used in STP are with volume, there will be 22.414 dm cube for 1 mole of the substance. The pressure will be 1 atmospheric pressure. N is equal to 1 mole. T taken in the Kelvin scale, it is 273. As I told you earlier, it must be converted into Kelvin scale for the correct one calculations, otherwise you will get a wrong answer. Now here we have the equation, that is P is equal to nRT. Find out from it the R. Rearrange this equation to find out the value of R. R is equal to Vp upon Nt. Now apply all the values we have written above, that is the value of volume, pressure, number of mole and that of temperature. You will get the value, that is 0.0821 dm cube atmosphere per Kelvin and per mole. This is the value at STP which you have to memorize, and it will be repeatedly used in the numericals. Now here, if we change the atmosphere by means of the millimeter He or by means of torrs, then what the value will change of this R? Or if we change the volume into centimeter cube, so here the changes which occurred by the one by one change of the pressure and the volume, it is mentioned here. Now look at this, the equation is 0.0821 dm cube into atmosphere per mole per Kelvin. If we remember the relation between the different units of pressure we have done earlier, 1 atmosphere is equal to 760 millimeter Hg or 760 torr. So instead of this atmosphere, write down 760 millimeter Hg and multiply the 760 millimeter Hg with the value of R. So what will you get? It will be 62.4 dm cube millimeter per mole per Kelvin. Okay, then in torr the value will be same. As I told you earlier, the relation between the HFG and that of the torr, both are equivalent. The value will be 62.4 dm cube torr per mole per Kelvin. Okay, now here the next one is, if we change the what you say the degree centigrade, what you say the volume into the centimeter cube, then now what to do? You have to we are changing from the bigger one unit to the smaller one unit, so you have to make use of the 1000 centimeter cubes. Okay, so multiply this value with 1000 centimeter cube. What the value will get, that is 62400 centimeter cubes torr per mole per Kelvin. This is how the value of R changes with the change of the units. Okay, now here it is given the value of R being calculated in SI units. In SI units, pressure will be taken in Newton per meter square and volume will be taken in meter cube units. So change it. That volume from dm cube to meter cube, it will be the relationship which is used. 1 dm cube is equal to 10 to the minus 3 meter cube. So value changes from 22.414 to 0.0224 meter cube. The pressure will be 101324 Newton per meter squares. Moles remain same and temperature remains same. Apply the formula PV is equal to nRT, rearrange it to take out the value of R, apply the values along with their units, and you will get the value of 8.3143 Newton meter per mole per Kelvin. This is the value of R in SI units. Right, now if we want to convert it into joules, so remember this relationship, 1 Newton meter is equal to 1 joule. So instead of this Newton meter, you can apply here 1 joule, right? Now the value will become R is equal to 8.3143 joules per mole per Kelvin. Sometimes you are asked to give the value in calories, then what to do? Then you have to learn the relation between joules and calories. 1 calorie is equal to 4.18 joules, right? So apply it here and multiply it with the value. You will get your answer in calories, right G? Now come to the next one. Here it is given an example, a solved one, that 4 grams of CH4 at 27 degrees centigrade and a pressure of 2.5 atmosphere occupy a volume of 2.46 dm cube. Calculate the value of R. Now it is quite easy. You have been given the values of pressure in atmosphere and the value of the volume in dm cube. So ultimately you should know that what you have to do, uh, convert the temperature into Kelvin. The number of moles you have to calculate now, 4 grams of CH4. How to calculate number of moles? N is equal to W by M, right? So 4 divided by 16, it will give you the moles, right? Now here you will get it. Apply it in the equation. What equation? PV is equal to nRT. Take out R. So you have to find out the value of R from it. So it will be R is equal to Vp upon NT. V is 2.5 atmosphere, 2.46 dm cube. Pressure given is 2.5 atmosphere. Moles, you can get it 0.25 moles or 1 upon 4 moles multiplied by 300 kelvins. So you are getting the answer 0.0821 dm cube atmosphere per mole per Kelvin. So this is the value of R in STP. Right, now come to the next one topic, a very important topic. Before I go this one, you have been given a number of the examples or a number of self-check are being given over there, so you have to do them as your assignment. Okay, now come to this one, deviation from ideal gas behavior. Now what are ideal gases and how do they deviate from the ideal gas behavior? As I told you earlier, ideal gas means the gas which obeys all laws, that is Joule's law, Boyle's law, Avogadro's law, at all the values of temperature and pressure, that will be considered as the ideal gas. But if it shows some other value rather than that being given by these laws, then it will be considered as the real gas, which deviates from the normal ideal gas behavior, right? So here we have been given that Vp is equal to nRT. The what you say, the this is the equation for the, this is general gas equation for the ideal gases, right? So what do you think about, are the gases real? What do you think, the gases, they are ideal? Two terms, as I told you, now two terms are there, one is ideal and the other one is the real gas, right? So what is the difference between these two? Now the none of the gas is ideal at all temperatures and pressure, but they behave differently at the different conditions of temperature and pressure, right? If you remember, when we have calculated for the absolute zero, we came to know about that when we are decreasing temperature, what happens? The molecules, they are losing their kinetic energy. When they are enclosed in a container, their movements become slow. They come closer as the volume is also decreased. When temperature decreases, volume also decreases. So when there is a decrease in the volume, what happens? There is observation that it changes its phase. Instead of that volume becomes zero, they changes their state. They may be converted into the gas, into the liquids, or may be converted into the solids. This is called a non-ideal behavior. This is called a non-ideal behavior, right? So there are certain conditions, we say the two parameters, one that is low temperature and the second one is the high pressure, at which the gases, they show deviation from the general gas ideal behavior, right? So these gases which are mentioned here, that is hydrogen, oxygen, nitrogen, methane and carbon dioxide, they are gases at room temperature, but at different conditions of temperature they disobey the gas laws. So that's why at those temperatures they are considered as the real gases, right? Now, now we have to tell why the real gases they deviate from the gas laws. कौन से ऐसे पॉइंट्स हैं जिनको कंसिडर करें तो आप कहेंगे कि गैसेस जो हैं वो रियल गैसेस कहलाती हैं. Why do they deviate, right? अच्छा, just consider एक कंटेनर सोचो और उसमें सोचें कि there is present a gas, okay? It is placed with the movable piston के साथ में attached है. आपने जो है एक्सटर्नल प्रेशर डिक्रीज कर दिया. अब डिक्रीज प्रेशर पे क्या होगा? द वॉल्यूम इनसाइड विल बी इंक्रीज अकॉर्डिंग टू बॉयल्स लॉ. दे आर रिलेटेड टू ईच अदर, राइट ना? सो क्या होगा? वॉल्यूम विल बी इंक्रीज. पार्टिकल्स जो है बहुत दूर दूर एक दूसरे से भागेंगे. दे विल बी अपार्ट फ्रॉम ईच अदर. एंड व्हाट विल हैपन नेक्स्ट? क्या उनके बीच में अट्रैक्टिव फोर्सेस होंगी? नो, दे आर फार from each other. Distance भी large है और size भी छोटे हैं. So there will be no attractive forces between them. So what happens? Right? अब क्या होगा? Suppose करें आपने pressure कर दिया increase. Right? और दूसरा काम आप क्या करें? अब जो समझें कि आपने टेम्परेचर बेसिकली आप डिक्रीज कर रहे हो जिसकी वजह से प्रेशर इनसाइड अल्टीमेटली खुद ब खुद डिक्रीज होता चला जाएगा. इनसाइड द कंटेनर की बात कर रही हूँ मैं, ठीक है? व्हाट इज गोइंग टू हैपन हियर? आपने टेम्परेचर को डिक्रीज करना शुरू किया टिल इट रीचेस इट्स कंडेंसेशन पॉइंट, कि आप एक पॉइंट और नीचे लाएंगे टेम्परेचर और ये लिक्विफाई कर जाएगा. बिफोर दिस क्या हो रहा है? आपने जो सब्सटेंस है उसके ऊपर प्रेशर इंक्रीज करते जा रहे हो. टेम्परेचर आपके पास में जो है वो डिक्रीज होता जा रहा है. टेम्परेचर डिक्रीज करने से मॉलिक्यूल्स की काइनेटिक एनर्जी जो है वो हो रही है कम, ठीक है? सो व्हाट हैपेंस नाउ? इट विल गेट सम, क्योंकि क्लोज आ गए हैं मॉलिक्यूल्स बिकॉज ऑफ द प्रेशर इंक्रीज की वजह से वॉल्यूम डिक्रीज हो गया है. सो व्हेन दे विल क्लोज टू ईच अदर क्या होगा? there will be the attractive forces which will dominate and it will change its state from gas to the liquid. Now it is given in the form of a table. Look at this. The example used is of hydrogen. The pressure in atmosphere that has been changed. Suppose three experiments are being done at different values of pressure and the volume. That is calculated. According to the Boyle's law, the relationship has been calculated. Suppose in the first experiment, the pressure was 0.1, right? It is a low pressure. So the volume in dm³ was 224.1, right? You know very well. Remember the relation that 1 atmosphere is equal to 22.414 dm³. So 0.1 will be equal to how much? 22.414 upon 1 multiplied by 0.1. So there will be the value 224.1. Now if we calculate the value of PV, it is 22.41. Okay. Now here we have the increase in pressure. Now you have increased pressure up to 50 atmosphere. अब 50 atmosphere pressure आपने increase किया. अब क्या होगा? Volume जो है ultimately अगर आप Boyle's law पे जाएं तो pressure volume they are related to each other, inversely relate कर रहे हैं, ठीक है? तो एक increase करोगे तो दूसरा decrease में जाएगा. तो volume is being decreased. It is 0.4634, right? वैल्यू PV की कांस्टेंट आनी चाहिए थी लेकिन आई तो नहीं. इट इज 23.71. ऑल्दो इट इज क्लोजर टू 22.41 लेकिन ये सेम तो नहीं है. आपने प्रेशर बढ़ा दिया 1000 डिग्री सेंटीग्रेड तक. अब आपके पास जो वॉल्यूम है दैट इज डिक्रीज मोर 0.384 और इस दफा P की वैल्यू बिल्कुल ही डिफरेंट आ रही है. इसका मतलब है that gas is not behaving ideally. It is disobeying the law at the different pressures and volumes, right? So this is what we say, the gas hydrogen, it is behaving as a real gas at these pressures, right? Now what are the causes for this? अब इसकी cause क्या है? वो कहते हैं there are two basic causes due to से दो postulates हैं of the, ये भी एक short question आपके पास में आता है, which postulates of the kinetic molecular theory or KMT they were found wrong, right? right? Or they are the faulty one assumptions, right? So you have to tell about them. Now here we have the two of them. The first one is intermolecular forces of attraction. We have considered, अगर आप चले जाएं पीछे KMT पे, तो it says that no attractive forces are present, attractive as well as repulsive forces are present among the particles of gas. एक तो ये था, ठीक है। और दूसरा आपके पास में ये है, द एक्चुअल वॉल्यूम ऑफ द गैस पार्टिकल इज नेग्लिजिबल एज कंपेयर टू द वॉल्यूम ऑफ द कंटेनर। इसको ऐसे समझें जैसे एक full one, suppose auditorium is there, a big one, a large one room, consider it as a container, और इसमें अगर आप एक मिट्टी का ज़र्रा लेते हैं तो इतने बड़े वॉल्यूम ऑफ और कंटेनर के लिहाज से व्हाट इज़ द वैल्यू ऑफ दैट वन, एक ज़र्रे की, एक पार्टिकल की क्या वैल्यू? नथिंग, राइट? तो वॉल्यूम ऑफ दैट पार्टिकल इज टेकन as negligible as compared to that of the volume of the container. So these two postulates are being considered as wrong, right? What about, now here it is given the deviation of the gases from the ideal behavior, or what about the reason for the gases to be real ones? So there are two conditions, that is at lower temperature and number two at high pressure. Now what happens to them? We can see very well that when at normal room temperature the particles of the gas, they are far apart from each other, or you say at a high temperature the particles, they have the maximum kinetic energy among them and they are far apart from each other. None of the what you say attractive forces are present between them, or you say they are in the random one moment, most disordered form, we call it as the gas particles they have. Now what happens when within a closed container, now consider a closed container in which a gas is being contained and you are decreasing the temperature of the gas, that means you are cooling it. When you will cool it, what happens? The kinetic energy of the molecules will become less. Slowly, gradually, the temperature is decreasing so that the kinetic energy is also decreasing. The molecules, they are coming closer to each other, and in doing so the attractive forces, they develop between them, and a temperature reaches above this one, the gas become liquefied, right? This temperature is termed as a critical temperature, after which the gas becomes liquid, right? So what happened, as you have decreased the temperature, there will be appearance of the intermolecular forces, right? So that the gases, they deviate from the normal behavior. What do you think about? Compare the two gases. One is SO2 and the other one is hydrogen gas. Here you have SO2 is having the larger one size. You can say it consists of one sulfur and two oxygen atoms in it, while hydrogen is consisting of two hydrogen atoms. The sizes are too small. One of hydrogen is having so small, while the SO2 is having a large size, right? So what you say, the from experiments it is confirmed that the liquefaction point of the SO2 is minus 10 degrees centigrade, while that of the hydrogen is minus 252.7 degrees centigrade. Means their liquefaction points are totally different from each other, right? Now what is the reason for it? Why don't they behave as, now they are behaving as a real gases at these temperatures, as they have converted into the liquids? Why? Why? Now the answer lies here. The when you are decreasing temperature, you are decreasing their kinetic energy. What do you think about? क्या room temperature पे सल्फर डाइऑक्साइड में और हाइड्रोजन में एक जैसी अट्रैक्टिव फोर्सेस होंगी, क्या डेवलप होना शुरू हो जाएंगी? द आंसर इज इन SO2 yes, there will be attractive forces developing, लेकिन वो अभी इस हद तक नहीं पहुंचेंगे कि गैस लिक्विफाई कर जाए. गैस को लिक्विफाई माइनस 10 डिग्री सेंटीग्रेड पे ही करना है, राइट? तो कंसिडर करें ज़रा अपने रूम टेम्परेचर इन कराची इन द विंटर सीजन, इट इज़ इन बिटवीन 20 to 30 डिग्रीज के बीच बीच में आपके पास में जा रहा होता है, ठीक है? सो व्हाट हैपन्स, यहाँ पे आपके पास में SO2 होगी तो कैसी, but it will having some of the attractive forces starting developing in June, क्योंकि आपके पास इससे नीचे जाएंगे टेम्परेचर अगर आप ज़ीरो पे लेकर आते हो तो ज़ीरो पे तो आप वाटर को ही देख लें, वाटर फ्रीजेस एट ज़ीरो, ठीक है। तो इसकी स्टेट में आप, और अगर आप कहें कि ये आपके पास में गैशियस स्टेट में, तो ये गैशियस स्टेट में तो 0 डिग्री सेंटीग्रेड पर एग्जिस्ट नहीं करता, ये आपका 100 डिग्री सेंटीग्रेड पर जो एग्जिस्ट करता है। तो अगर आप टेम्परेचर डाउन करना शुरू करेंगे तो रूम टेम्परेचर पे ये आपको, इसका मतलब है सिग्निफिकेंट फोर्सेस इसमें हैं जब आपके पास टेम्परेचर, तो इट इज गोइंग टू अपीयर एज अ लिक्विड। सिमिलरली सल्फर डाइऑक्साइड, इसको -10 डिग्री सेंटीग्रेड से पहले वो पॉइंट आ जाएगा जब नेक्स्ट ऑनवर्ड टेम्परेचर इसको कन्वर्ट कर दे इनटू द लिक्विड। सो हियर इट विल बी, ये आपके पास में अट्रैक्टिव फोर्सेस इसमें काफ़ी ज़्यादा होंगी एज कम्पेयर टू दैट ऑफ हाइड्रोजन। हाइड्रोजन में बिल्कुल नहीं आपको मिलेंगे, हाइड्रोजन आपको गैस ही मिलेगा, चाहे आप -110 पे भी चले जाएं फिर भी गैस ही मिलेगा, ठीक है, क्योंकि इसका टेम्परेचर बहुत बहुत लो है। अट्रैक्टिव फोर्सेस बहुत ज़्यादा देर में जाके इसमें डेवलप होना शुरू होंगी क्योंकि इसका साइज इज बहुत स्मॉल, राइट। नाउ कम टू द नेक्स्ट वन, हियर वी हैव द सेकंड फैक्टर, दैट इज दैट हाई प्रेशर। जैसे मैंने पहले आपसे कहा, हाई प्रेशर पे क्या होता है, हाई प्रेशर पे यू आर मेकिंग द पार्टिकल्स ऑफ द कंटेनर टू कम क्लोज टुगेदर। आप प्रेशर इंक्रीज कर रहे हैं आउटसाइड, एटमॉस्फेरिक प्रेशर आप बढ़ा रहे हो, इंटरनली भी आपके पास प्रेशर इंक्रीज कर रहा है क्योंकि पार्टिकल्स आर रनिंग, काइनेटिक एनर्जी उनमें बहुत हाई हो जाएगी व्हेन दे आर कोलाइडिंग विद ईच अदर। स्लोली ग्रेजुअली जैसे जैसे प्रेशर इंक्रीज करते चले जाओगे वैसे वैसे उनके डिस्टेंसेस कम होते चले जाएंगे, और जब डिस्टेंसेस कम होते चले जाएंगे तो फिर उनके जो वॉल्यूम्स हैं वो आपके पास में ज़ीरो की तरफ तो नहीं जाएगा, उस वॉल्यूम में जो कि कंसिडर किया गया है विद इन द कंटेनर, अब वो नेग्लिजिबल नहीं रहेंगे, ठीक है। कंपेयर करें अ लार्ज रूम जिसमें आपने सपोज 1 मोल पार्टिकल्स छोड़े हुए हैं, दे विल ऑक्यूपाई द होल स्पेस विद इन दैट रूम, और कंसिडर करें वही 1 मोल लेकिन इन अ वेरी, आपने स्क्वीज कर दिया उस रूम को, स्क्वीज करते करते आप बहुत नीचे ले आए। स्क्वीज कैसे किया आपने? बाय इंक्रीजिंग द प्रेशर। अब क्या होगा जरा सोचें, अब आपकी क्लास में एक चेयर पड़ी है, वो क्या उसका वॉल्यूम नेग्लिजिबल है इन दैट क्लास? नो, राइट। उसी को अगर हम एक और छोटे से रूम में रखते, वहाँ उसका वॉल्यूम और ज़्यादा नेग्लिजिबल नहीं रहेगा एज कंपेयर टू दैट ऑफ द रूम। कैपेसिटी के लिहाज से आपके पास में उसका कुछ वॉल्यूम बन जाएगा, पेरेंट्स में होगा, आपको पता होगा कि इट इज़ कैरिंग सम वॉल्यूम इन इट, राइट। सो व्हाट हैपेंस हियर, द फिर से क्या चीज़ बनना शुरू हो गई? अट्रैक्टिव फोर्स। तो साइजेस नेग्लिजिबल नहीं रहे, आपके पास में अट्रैक्टिव फोर्सेस फिर से डेवलप करना शुरू कर जाएंगे, और हाई प्रेशर पे भी गैसेस जो हैं दे विल डेविएट फ्रॉम दैट ऑफ द नॉर्मल बिहेवियर। तो हम कहेंगे एट हाई प्रेशर एंड एट द लो टेम्परेचर द गैसेस दे बिहेव non-ideally, or they behave as real gases. Right here it is given a graph. You can see in the center there is present a line which shows you PV is equal to RT, means N is equal to PV upon RT. For a ideal gas, this value should be 1 मोल आनी चाहिए ये वैल्यू, ठीक है, 1 की वैल्यू। एंड दिस इज कॉल्ड द कंप्रेसिबिलिटी फैक्टर, PV upon RT is called a compressibility factor and its value should be 1, ठीक है। लेकिन जरा सोच देखें इन गैसेस को, यू हैव हाइड्रोजन इन इट, यू हैव मीथेन, इथेन, नाइट्रोजन, अमोनिया, these gases are presented here, right? So here at the x-axis there is given pressure, while on the other side on the y-axis it is given PV upon RT, that is compressibility factor. Now you are going to compress the gases. You can see the gases, they are originating from that of the point 1 at zero pressure. At zero pressure, maximum of them they have the point 1, but as you are increasing pressure, the gases, instead of going straight, they are moving down or upwards. Here you can see, right? Now, why does it happen? This happened due to the volume of the gas particles never remained negligible as the pressure is increased. So the gases, they deviate from the ideal behavior. For an ideal gas, there should be a straight line for all the values of pressure and volume, but it is not as it is mentioned here, right? This graph is taken at 0 degree centigrades, right? Here it is given. Okay, now temperature throughout will remain same. You are not going to change it, but the pressure is going to be changed. All the gases, they have started from the point 1, that is PV upon RT, जब फैक्टर 1 की वैल्यू कैरी कर रहा है वहीं से ओरिजिनेट हो रही है, लेकिन जैसे जैसे आप प्रेशर इंक्रीज करते जा रहे हो, द डेविएशन इज ऑन इंक्रीज. कुछ गैसेस बहुत डाउनवर्ड आके फिर नीचे गए हैं, ठीक है. तो गुड गैसेस जो हैं दे आर मूविंग अब ऊपर से ही आपके पास में और फर्दर इन्होंने डेविएट कर लिया टुवर्ड्स दैट अदर. दिस इज ड्यू टू इनके साइजेस, बेसिकली दे आर डिफरेंट फ्रॉम ईच अदर. So that's why we get a difference in their deviations, right? Maximum is given by ammonia क्योंकि ये polar molecule होता है, तो attractive forces तो already इसमें हैं, right? The others, they are non-polars. Okay, so there comes a difference. Hydrogen ज़्यादा close है, वो कुछ कम deviate कर रहा है, लेकिन कर रहा है जैसे जैसे pressure increase हो रहा है, it is deviating from the general behavior, right? This is what we say, the graphical presentation. Here the question comes, what is compressibility factor, right? And graphically present that the gases, they show deviation from the normal behaviors, or you can say this is the graph for the real gases, right? So read it. I hope you will understand it. If you have some difficulty, so you can ask again. Okay.